So good afternoon to one and all. Once again, I welcome back you all for the power quality and facts practical session. So what I will do, I will open once again the syllabus related things. Directly, I will open the university syllabus only now. Okay, you'll understand what they have given to do the practical. Actually, I have checked your syllabus. So in this syllabus, they have not mentioned any practical syllabus for you people. Is it visible? Visible है क्या? The screen is visible.
Yes, sir.
Why these people are joining now unnecessarily? They are disturbing. 23, 30. Who is Siddhi Sinde? So I will not accept those names and other things. If anybody of your friend is there, we'll let them to change their name. Okay. Somebody is there in the waiting rooms. The name is there, Siddhi Sinde. I don't know. Okay. So according to your syllabus with effect from 21-22, CS. This is the structure first semester of Jahina. Okay. Is it visible now? Yes. Roll number 1.
Yes, sir.
Visible hai screen?
Huh?
Screen is visible.
Yes, sir.
Okay. So the power, quality, and facts, actually, they have mentioned the practical here now, the practical period. We have to conduct 2 hours per week. Okay. We have to conduct 2 hours per week practical, but I have checked that one credit is there for your practical and oral examination is there. There is no performance based practicals actually. So once I have scrolled down this one, where I will go to the, just a minute, semester 1, that is industrial drive. I'll check all the things. I have checked all the things once again also. See here, this is like list of experiments they have given for this other subjects. Okay. Electrical audit, switchgear and production, drives they have given. But here, they have not mentioned any syllabus. This is the power quality syllabus. Okay. See, yes, in the today class and yesterday class, we have discussed about all the chapters. We have told the introduction of all the chapters. But when I have scrolled down, I'm not getting the syllabus for the practical actually. So the university has not mentioned any syllabus for the practical. For the internal continuous assessment, they have given that minimum 6 assignments in above syllabus. 6 assignments we have to take. 1 assignment from each chapter we have to conduct. Okay, even they have not mentioned any textbooks also. Only the facts textbooks they have mentioned. The power quality textbooks also they have not mentioned. That is next, the syllabus is starting. So what I will do, we have the practical they have mentioned for 1 credit means weekly 2 hours we have to conduct a practical at least. Okay, for that reason I will conduct every week around 7 to 8 practicals in MATLAB. All of you are familiar with MATLAB, I think. Yes or no? All of you are familiar with MATLAB. Starting in the CAD subject when the computers we brought, but lockdown, because of the lockdown if you have not performed, and after that still you people are sitting in a home and you are studying. Okay, so Today we are going to discuss the experiment number 1. So to give the introduction about the practical, already you are in the last semester. Some people, few people are doing in the project in MATLAB and all the things. Okay, for that reason, so there is no syllabus for the practical. For that reason, what I will do generally, I will take one experiment on the simulation of that line to ground faults, line to line faults. By considering like that, we can do the simulation work. We can do that one. Okay, that is experiment number 1, voltage measurement for line to line and line to ground fault. Or line to ground fault we will consider today, or line to line anyone we will consider here. So what will happen if the line to ground fault occurs? Means that is voltage sag is nothing but the voltage will be start to decreases in that particular. If the load increases, the current will be increases and voltage will be decreases. All of you know that characteristics of that power system here. Now sag is nothing but what we are not going to how it is going to occur the sag and all the things we will discuss in the theory part. Still theory is not yet discussed, but just for your knowledge, a sag is nothing but the voltage decrease in between 0.1 to 0.9 per unit. Actually our power system, the standard quality of the voltage is 1 per unit should be there. 1 per unit should be there, but because of the fault or over voltages or any harmonics transients, what will happen, the voltage will decreases, and if voltage is reduce or decreases to in between 0.1 to 0.9 per unit in RMS voltage or current at the power frequency, same power frequency, from 0.5 to 5 cycles to 1 minute, actually 0.5 seconds to 1 minute, we can consider that one here. Okay, 0.5 seconds to 1 minute, during 1 minute if it is occurred, that is nothing but we are going to call here as a sag. Sag durations are subdivided here into some 3 categories. They have divided that one. So that is instantaneous, it may be momentary, for some moment only, some instantaneous it is coming, for some moments it is coming, and temporarily suddenly the fault will occur and it will remove that one part. So that is temporary we are going to call here. So the causes of sag because of the faults, it may be line to line or line to ground fault, or energization of heavy loads, or starting of large motors, this will come over there. So how we have to do? So I will take some 3-phase power supply. I will take first now. I will take the 3-phase power supply. I will consider. So all of you are familiar with MATLAB, I think. I'm considering that one. Okay. That is here the generator I am going to use here now. 3-phase generation, it will get 3 lines, we are going to get that one. Okay, that is L1 kV generation we are doing here. L1 kV generation at 50 hertz here. Now the frequency I will consider as 50 hertz only, I will consider that one. So next what we will do, we will the supply after generation, what we are going to do that one, we are going to step down that one directly. I will make a fault at 400 volts. So for that reason, to do the step down, I will use a 3-phase transformer. I will use here 3-phase transformer I will use, and this 3-phase transformer, what it will do, L1 kV to L1 kV to L1 kV to 400 volts, it is going to convert that one. I will use L1 kV to 400 at 50 hertz. The L1 kV to 50 hertz. The output of this 3-phase transformer we are going to use, that is 3 outputs we are going to get here now. So that one what we will do here, I will use the circuit breakers. I am going to use that one here. Here can use the circuit breakers here now. After circuit breakers, we can connect this one into load here, or in between this you can connect the measuring block here now. The voltage measurement blocks, you can 3-phase measurement, you can do that one. VI measurement, we can, I will write directly VI measurement block, we can connect it, measure VI measurement blocks, we can use that one, and that we are going to connect into the load here now. 3 loads I will use. It may be RLC load. We are going to connect that one here. 3 phase को RLC load ही रहते हैं ना? Yes or no? Some people are joining. Roll number 35 Gawani. Okay. So here, this is a circuit breaker is that here voltage measurement we are doing, we are applying the load here. We are applying a load here. So what is our waveforms for this one? How will get the waveforms? Anybody? The sinusoidal waveforms we are going to get? Yes or no? So how will get? I will consider the waveforms here for this one. It will be Jesus, I'm not getting the straight line. I don't have the mouse. But okay. This much is enough, I think. This is the x-axis, y-axis. Okay. I'll start the R phase, that is sinusoidal waveforms. I am going to start that one. Okay. So 1 per unit, I will consider that. Some 2 cycles, I will 2-3 cycles, I will consider this one. आवाज आ रहा है क्या? Is it audible or not? सब लोग silent बैठे. All of you are sitting silently. Is it audible or not?
Yes, sir, audible.
Okay. Next, what we have to do, I will take different color. That is, after 120 degree, the 3 phase, we know that one, the 3 phase character, each phase 120 degree, the phase difference is there. Like this, we are after 120 degree, it is going to start the next page. Next page, we are going to, just a minute, something happened here now. Where's the eraser? Yellow color visible nahi hai na? Okay, I will take different colors. I think, okay. So this dark color I will take. This is, so from after 120 degree, it will start the next phase 2. That one, phase 2. That is phase 2 now. Okay, next the phase 3, from here to here 120 degree, it is going to start here now. That is phase 3 we are going to discuss. Okay, here now. See, this is R, Y and V. Normally, without any faults, these are operating at normal frequency, and the voltage we are getting, the output we are getting 1 per unit. We are going to get 1 per unit. We are going to get. If anything happened, suppose one fault will be occurred over there. If anything happened and suppose fault occurs, then what will happen? The voltage of that particular line or that particular phase, it is going to fall over. It is going to fall. Suppose I want to apply the load or fault at the fault I will apply here now. So where I will apply to the line here. So here I will apply, suppose I will consider one fault that is called line to ground fault. I am going to consider here. Okay, line to ground fault I am going to consider. Suppose this fault will occur at any one line here, that is phase A. If it is fault is occurred, and that condition, what will happen, suppose for particular after suppose second cycle here now, this the voltage of this particular phase, it is going to decrease for that particular time of the fault. Suddenly it will drops and it will reduces like this here. The some spikes are downside voltages we are going to get here. So this is just how we are going to, for this one, the three-phase power supply is required. So three-phase transformer is required, three-phase circuit breaker is required, some voltage current measurement block is required, and this one, the RLC load is required to measure the voltage here now. That is scope we are going to use that one here in the MATLAB. I don't know how many of you are familiar with MATLAB. I don't know about that one. So what I will do, this whatever the blocks I have drawn and whatever the waveforms I have drawn here now, I will show you in the MATLAB today session. Okay. किसी को कुछ पूछना है तो पूछ सकते हैं. Any doubts? किसी को कुछ पूछना है? हेलो, आवाज आ रहा है क्या नहीं? सौरभ मुळे, आर यू देयर? मुळे सौरभ, सौरभ मुळे, फॉर्मेलिटी के लिए ज्वाइन नहीं करने का, अभी रोल नंबर चेंज किया आप. शिवाजी सुरव से. What is your roll number?
62.
This is the last warning to you. Next ऐसा ही सिर्फ नाम से ज्वाइन किया ना, मैंने एडमिट ही नहीं करता हूँ आपको. मुळे, you are also same in you are also same condition is applied, because you whenever file admitting to the meter, your name was only Saurabh Mule. Now you have entered 53, and Shivaji Survasi also same. Someone is already in the waiting room. I don't know who is that one. Siddhi. Okay. Yes. Okay. So this block will perform in the MATLAB. So I will close this one. If same blocks I told that one, three-phase power supply will take, and transformer, one circuit breaker, one voltage and current measurement block, and some load we are going to take. First we will run this block, okay, and we will observe the waveforms. After that I will take some fault system, I will take that one, and we can apply for phase line to ground, second line to ground we can apply, or line to line we can apply, and we will see that one. Okay, can I use the MATLAB now? I will share my full screen. I will say to you two peoples, then it will become easy. What is this? See here, the MATLAB is there. I'll open this MATLAB. See, I already have done this, performed the practical. I don't know where I saved that one. Here. So power quality sag, I have performed that one. Then also let it open. It will take so much time to open the MATLAB. Okay. So the topic of this one is very interesting actually. The power quality is not that much boring subject. It is a very interesting subject. I can say interesting, but you people, I don't know your response and all the things. Fault study किया ना switch gear production में already? Are you studied or not faults? See, ऐसा है तो नहीं चलते मैडम. कोई तो रिप्लाई दे दो ना. सुवर्ण, पूनम, साक्षी, अमृता, प्रज्ञा, सागर, बानु से भी है. दीपक हमें है क्या? हमें दीपक, आर यू देयर? खरात गोरखनाथ, डोंगरे महेश, महेश डोंगरे. महेश डोंगरे. I will check that one if it is opened or not. Okay, the MATLAB is open now. I will click on this simulating block now here. Click on the simulink, it is opening now. Okay, so already I have performed that one. What I will do, instead of taking the new model, I will open that one. I click on open. So if you while performing this one, you have to do that one. Blank model you have to take. Blank model you have to take that one. So it is taking time. Okay, it is asking the path. I have saved on the desktop this one. Okay. So much time it will take for the who is having 8 GB RAM. For them it will become easy. Okay, see here. This one we are going to discuss here now. See here, the three-phase sources I have chosen here now. Three-phase source I have chosen, and three-phase transformer, that is two winding. Three-phase circuit breaker I have used here now, and this is voltage measurement. One load RLC load I have used parallel loads. The load will be parallel only, no? So series also we can apply. So parallel loads I have used, and one scope for the measurement I have used here. So is it okay, or can I take the blocks? If you want to take the blocks, means just what you have to do, to click on the library. I will tell how to take the blocks also. You can click on the library first. Okay. Then what you do, all these are available in the Simscape here. Now you have to click on the Simscape here. You click on Simscape. Here the power system part is there. The power system part, you double click on this, and some specialized technologies are there. Here you click on this. See here, some fundamental blocks are there. We want the fundamental blocks. You have to click on that. And here, to get the three-phase sources, you have to get the electrical sources. You have to click on that. So here, three-phase source is there. What you have to do, just click on that one and add to model. You have to click on that one, add to model. It will come over there here. See, it came here. Like that, all the equipments are available in the power system. You have to go back here now. Again, you have to go back. You can take some elements also, you can take, or measurement you can take. So here I will click on that. Measurements you take down. So from the measurement here, three-phase VI measurement is there. Here you can take, or directly you can search the components also. By taking all the components, what you have to do, according to that, you have to, what you have to do, you have to joint this three-phase supply is there, source is there. So which one we have to give the transformer here? Now I will remove all. Suppose I have taken all the blocks we have taken, and like that we will think that, and I will remove all the supply. How we have to joint, I will tell you. So all the blocks we have taken, this is the power GUI, which one? To give the power supply to all the blocks. This one, power GUI block we are going to use. So here three-phase source of supply is there. Suppose it will comes like this here now. See here, all the blocks, it will comes like this. You don't know where which block is there. Okay. Now what we have to do, we have to make all the blocks separate first. All the blocks separate first, and in the flow we have to set all that one. First we have to separate all the blocks. We have to separate all the blocks. Okay. So first, which will come, three-phase source, it will come. Next is required, that is called, which one it is required? This three-phase, not breaker. There is a transformer is required. Next I have to set this one here, the transformer. I will add here now. I will place here now. Transformer give us what is required, that is called circuit breaker is required. I will fix the circuit breaker here now. Circuit breaker I will add here now. And after that one, the fault is not required now. Then the voltage current measurement VI measurement block is required. Then we have to add the load, we have to add here now, and the scope I am connecting here now. What we have to do here, A to A, give the transformer input from the supply input winding transformer, A to A, B to B, and C to C. We have to join all these three. We have to join here. Next, the output of the transformer we are going to give to the circuit breaker here now. That is A to A, B to B, and C to C here. So set give to the output here. Next, the output of the circuit breaker you have to give to the voltage measurement current blocks here now. So that is A to A, B to B, and C to C here we have to. Then the phase A is connected to the phase A load, phase B is connected to the phase B load, phase C is connected to the phase C load here. So for the measurement, what we have to do, I want to measure three-phase voltage, that is called here VABC I have given here. VABC I have given over there. I have given over there. Good. Okay. So next, what we have to do? What is our requirement? What is the input? How much generation we want? Anyone, can you tell me how much we are generating in India? How much voltage we are generating in India? Deepali. Medkari Deepali, how much we are generating? Munguskar. Roll number 54. Roll number 19. I asked last time this is. 19 is absent. If you are not ready to reply, then I will put directly absent. Absent डालने के बाद ही आवाज आता है क्या आपका? How much voltage we are generating in India? Generating station, how much voltage we are generating? You have visited industrial visit also you have done. So L1 kV, the generation we are taking here now. So L1 into 10 to the power of 3 is nothing but L1 kV we are going to consider. So phase angle of the first phase, that is called 0. It should have to start from 0 here now. Okay, the first phase, it should have to start from 0 here now. If you want to, suppose it should have to start from after 90 degree, then you can give 90 also here. It will start from 90 degree. So the frequency of that generation is 50. The power frequency is 50 is there. So other things, no need to touch that. Other things, you should not touch anything. So only we have to change the voltage and phase angle for phase A, first phase. And next, what we have to do? We have to set the frequency here. So then we have to, I'll clear all the things. 0, then we have to apply, then we have to click on OK. We have to click on OK. Okay, next, this generation part is over now. Generation, how much we have to generate, we have fixed that one. Then the transformer we are using, that transformer we are using 2 winding transformer, we have mentioned that one, but that is L1 kV to L1 kV bar 400 volt our requirement is there. L1 kV to 400 volt requirement is there. I will write L1 kV to 400. The input we have to set as L1 kV. I'll set input here now. See here, this is the configuration, that is winding the bus admittance matrix we have used, YZ and all things. Here we have to click on the parameters here now. See here. So nominal power and frequency here now. How much volt ampere, suppose